Welcome students. Now we are going to take a view on precast concrete products. So these are the precast concrete products are the products which are casted on site or in situ products. So these are having huge impact over the construction industries. Because of this, we can construct or build huge structures in a few months or in few days, as these materials are casted and then implemented over the sites, and that's why they have a good quality assurance. And because of these properties, they are used hugely for any kind of construction works. So following are the benefits of the precast concrete products. Design flexibility: we can check or test a product before its implementation, so that's why we can change shapes or the size or the any kind of changes we can made before the implementation. Then control production: there is no wastage of any kind of product or any kind of object during the construction, as these are in situ products or can be directly modified or constructed over the site also. That's why we can control its production. Then PCI certificate, that is a quality assurance certificate. Then safety and security: so during this construction work, we can produce a great safety towards the workers. Then sustainability, then layout flexibility, low maintenance works, acoustical control, mold resistance, then control over the environmental effect, then expansion capabilities and the economy. So that are the different benefits of the precast concrete products. The next, design flexibility. So here we can observe these are the precasted walls or the uh, panels which are casted before the construction work, and then they are implemented or bolted on the site. Then these are the exterior, having very good exterior finish. Then stucco paints, ceramic tiles, brick veneer, then stone veneer and terracotta. These are the examples of precast materials. Then control production: the casting component under the factory controlled condition benefits a project in many ways. They can more control over the final appearance, then tighter the tolerance, then precast as a team member, the elimination of the several trades and the materials, the production of regardless of weather conditions. We can control all the quality parameters just because of they are precasted. Then safety and security: it produce more safety towards workers. Then it provides the safety towards the fires, earthquake, then vermin resistant, blast and wind resistance. So next product, that is a glass. As a glass generally utilized in many malls, that are the fiber glasses, produce good resistance to the fire, water resistance. They are flexible and produce, and they are also a cheaper in cost and lightweight. That's why they are oftenly used for the partition walls for the decorative purposes. The general property of the glass are they are amorphous solids, no definite melting point, very brittle, then soften on heating, can absorb, reflect and transmit the lights, having good electrical insulator, affected by the alkalis, no affected by airs, water, acid and chemical reagent, but soluble in highly concentrated or uh, they are soluble in highly concentrated acids and possesses a high compressive strength, and say it does not have any crystalline structure. No slippage between the panels can occur. Then light in weight because of it has homogeneous internal structure similar to the liquids. Types of glasses are soda lime glass, potash lime or the hard glass, then lead glass, then borosilicate, glass or the Pyrex glass or Gina glass, alumina silicate glass, optical or the crude glass, glass wool, quartz glass, and the copper glasses. So these are the different types of glasses generally used for the construction works. Then it produces great bullet resisting or the safety glasses. Then frosty glass, glass blocks, glass slabs, and the glass pipes. These are the different uses of glasses. And what are the properties of the glasses which considered as a good construction material? First, viscosity. The viscosity of glass changes continuously with the temperature without a critical point. Therefore, it is useful to set up a references viscosity for which corresponding temperatures can be determined by a standard procedures. Generally, the three such reference point are used. The point at which the viscosity of glass is 10° poise is called as a softening point, and at this temperature glass is slowly deformed. Second, that is annealing point. It is a point at which the viscosity of glass metal becomes 10^3 poise. Then at this temperature the stresses of the glass articles on 6 mm thick can be sustainably relieved in a 15 minutes. Then the temperature at which the viscosity of a glass material is 10^14.5 poise is called as a strain point. So this is all about the property of viscosity. Then thermal expansion. The coefficient of expansion mainly depends on the composition of the glass. As the composition changes, the coefficient of expansion also changes. As we increase the temperature or the load, then expansion is carried out. Sometimes due to the internal frictional resistance, the thermal expansion carried out. Okay. But as percentage of alkali oxide decreases, the coefficient of expansion also decreases. In case of fused silica glass, the coefficient of expansion is around 5 into 10 raised to minus 7%. Then this is because fused silica contains a minute traces of sodium oxide. If borium trioxide is added instead of sodium oxide, the coefficient of expansion decreases. Then thermal endurance. The thermal endurance of the glass is a measure of its ability to withstand rapid or uneven changes in the temperature without breaking. High thermal endurance is necessary for the glasses. So that is about the thermal endurance. And the value of coefficient of expansion is small, then the thermal endurance is very high. Okay. Then the thinner the glass, the less is its break due to the thermal shock. Then glass can be withstand a greater changes in a thermal or the temperature stresses. When the temperature is increased, then can withstand a smaller changes in the temperature when the temperature is decreased. Then thermal conductivity is the rate of transfer of heat along with the body by conduction. The thermal conductivity of most type of glass at a 0° Celsius ranges from 1.5 to 3.5 10 raised to minus 3. So that is about the thermal conductivity. So the thermal endurance indicates the resistance to the thermal changes without breaking. Then thermal expansion, which indicates while increasing in temperature, thermal expansion increases. So that should be limited to the 5 into 10 raised to minus 7. In optical properties, the most important property of the glass, that is optical property. This is the dispersion and the transmission. The index of diffraction can be varied from 1.45 to 2. The rate of change of refractive index with respect to the wavelength, that is a dispersion, is usually measured by the value that can be varied from 25 to 70. So this optical property indicate the dispersion or the transmission of the lights. Then electrical property. In general, most type of commercial glasses are excellent electrical insulating material. Okay. At a room temperature, the volume resistivity is usually 10 raised to 12 ohm per centimeter or higher. But for good quality of glass, the value should be around 10 raised to 16 to 10 raised to 18 ohm per cm. Volume of resistivity drops down as temperature increases. So resistivity is mainly depend upon the temperature effect. At a melting temperature, the glass is fairly good conducting a glass with a low electric constant. Then mechanical strength.